Hey there! This week in Physics 2211, we went over a lot of things. We covered important things such as Newton's second law, motion video analysis and tracker, the momentum principle, comparing model predictions to observations for constant velocity, using a spreadsheet, recording observations on video, pointers on creating a lab video, drag forces, and spring forces. First, we talked about Newton's second law of motion, which says that if we watch our object and measure the change in velocity during a specified time interval, then the ratio of change in velocity to the change in time is equal to the total pushes and pulls on our object divided by the mass of the object. Regarding Newton's second law of motion, I've always been familiar with the equation F equals mass times acceleration, but before this class I hadn't really seen it written out in this form. Another thing that I found interesting that I didn't really consider before is that Newton's second law with a net force of zero is just Newton's first law, in which there are no net interactions and there is constant velocity motion. Another thing I learned about Newton's second law is that it's essentially the momentum principle. If you take Newton's second law equation on the top and then multiply both sides by mass, you get momentum, which is represented by p. The momentum principle and Newton's second law are valuable equations for predicting motion in the future in between two time intervals. As you can see in the first equation, you can find the velocity at the second time interval using Newton's second law, and then you can use that velocity into the position equation to find the new position. You can then repeat this process over and over to predict further into the future. However, this process can be time-consuming and tedious, and that is where programming comes into play. Programming is something I have very little experience with so far personally yet, but it's what sparked my interest and curiosity the most this week. I found it really interesting to kind of go through the logical process of how it works, and I find it very applicable to my major of BME as I'm interested in things down the road such as programming for medical devices and possibly taking courses in robotics and things like that. Additionally, as a music tech minor, we are working in programming and coding in a different sense with audio and a different program software, but looking into resources that help me with that sort of programming and also looking online at like sample programs and the help mentioned in the tracker, I think are resources to help me develop a more efficient process of programming. When repeatedly calculating the velocity observed in the constant velocity lab versus model behavior via programming, it made sense to me that first you need to establish initial conditions like mass and time. It was interesting to see how, in the programming language, that is done with assignment statements, supplementary comments, and how you cannot assign a variable backwards as shown in this error. It was a little confusing to me at first how the initial and final velocity seemed to be equal in the programming language, but then once you look at it as an assignment statement, it makes sense, and the computer does it over and over and over again to constantly get the new final velocity as shown in the full program. When actually analyzing the motion in Tracker, there's a few things that you need to do that are important for actual accurate analysis. One is you need to specify the video frames for your analysis, and you shouldn't start at the beginning because the initial speeding up from rest is not what you're trying to observe. Another thing you'll want to do is choose the coordinate system in your video, and you want to identify your object's position in video frames. An important reiteration in terms of graphing that I took away from this lab is that when the velocity is constant, so is the slope, and when the velocity isn't constant, the slope isn't either. There are many forces that can come into play in falling objects. One that comes to mind probably automatically is gravity, but other things, drag forces, which are forces that act in the opposite direction of motion, such as air resistance, should also be considered. One thing about drag forces that you may have already observed in common life experiences is that the faster you go, the more air resistance or drag force you will have in the opposing direction of the motion. This equation, you can see that the magnitude of the drag force is directly correlated to the velocity. Additionally, the direction is in the opposite direction of the motion, hence giving you the negative scalar times the velocity vector to equal the drag force. The last thing we discussed this week were spring forces. Here you can see that the magnitude of the spring force is proportional to the magnitude of the stretch, which is the absolute value of the difference between L and L0, aka S. In all honesty, spring forces are probably what I'm the most confused on still, and what I'm going to have to spend a little more time on, and I'll probably go through the book, and obviously examples in lecture and things like that. And so thank you for watching the video, and that is my recap of week 2.